Hello, welcome back. This is question number 5. We're going to continue on with the 2021 BC Calculus exam. And it says, let y equal f of x be a particular solution to this differential equation. And they give us the initial condition, 1, 4, and it can be shown that the second derivative is also 4 at x equals 1. Now they give me this initial point here, 1, 4, and let's see what they're going to ask us about this. They say, write the second degree Taylor polynomial. Alright, second degree Taylor. Well, we know Taylor as our rule. That it says that the nth derivative at c over n factorial x minus c to the n. So we want to write a second degree Taylor polynomial, so we're looking at degree 2, centered at x equals 1, and then we're going to use this polynomial to approximate the value of the function at 2. So let's go and generate our function here, our Taylor polynomial. So the first thing we need is the zeroth derivative at 1. Well, that's really just the value of the function, and they told us that is just equal to 4. Next, we're going to need the derivative at 1. To do this, we're looking at the derivative that they give us. That's just y x times natural log of x. Well, this is just from our function, so we know the point of y is 4 times x, which is 1, times the natural log of 1, which is all just becomes 0 here. And we can also take a look at the value of the second derivative at 1, and they tell us that's 4. Interesting. Now, just kind of thinking about this, now notice, for a function, it has a horizontal tangent at 1, 4, and it's concave up. So we already know that this is going to be a minimum value right there. Maybe we might see that. I don't know. I haven't gotten that far yet. So now we're going to go ahead and write our Taylor polynomial. It's a second degree Taylor polynomial equals 4, I'm using my polynomial rule right here, plus 0, don't worry about that. So plus this 4, and remember, this is 2, so it comes over 2 factorial, and then x minus c, which is our 1, squared. And there's our Taylor polynomial. Next, it asks me to approximate f of 2. Well, f of 2 is approximately, and I'm just going to use this, 4 plus, this just becomes 2 times 2 minus 1 squared, and that just becomes 6. And that's not too bad to do right there. Part B says use Euler's method. This is our tangent line on steroids, starting at x equals 1 with 2 equal steps to approximate f of 2. Show the work. All right, so we're starting at 1 and we're ending at 2. So we want an equal step. So my first step is going to take us to 1.5. So let's talk about step 1. Are we having some fun? Step 1, we need a point. This is a tangent line. The point they give me, again, is 1, 4. The slope, that's our dy dx from our slope up here. And we already actually know the slope here. We got that from part A. We already know that that's 0. So my tangent line, y minus 4 equals 0, x minus 1. I'm going to plug in my first x value, which is 1.5, and we just get y is 4. When we go to step 2, just me and you. Sorry, my best Donnie Osmond. Not Donnie Osmond. Oh my God, Donnie Wahlberg. Terrible. Sorry about that. So my next point is going to be my x value is 1.5, and my y value is 4. To get the slope, we're again going to use our derivative, and this becomes y, which is 4 times 1.5 times the natural log of 1.5. And if I simplify that, that becomes 6 natural log 1.5. So my tangent line, y minus 4 equals 6 natural log of 1.5, x minus 1.5. And now we do our second step and plug in 2. Let x equal 2, and we're going to get y equals 6 natural log 1.5. Plug in the 2 here, and we get 0.5 plus 4. And I'm just going to leave that alone. Okay, I'm just going to leave that alone. I mean, I guess you could say, well, it says 0.5 times 6, which is 3 natural log 1.5 plus 4. But that's okay. Just leave it alone. All right, part C. This is one I wanted to get to. This is the fun one. We haven't seen one of these in a while. We have to solve a differential equation. So we want to solve this now given the initial condition. And this one's not so much fun to solve. So let's see here. So the first thing we're going to do is we are going to separate our variables. Y is to one side, x is to the other. And that's going to become 1 over y dy equals x natural log of x dx. Now normally the AP will give you a point for this. We're going to integrate both sides. This side is very easy to do. But I want to focus on this part. Literally, this is integration by parts. So we're going to let u equal the natural log of x. You will, anytime you have natural log of x of u, anytime you have natural log of x and you integrate, that's going to be your u. Our dv would then be x dx. So we would get du becomes 1 over x dx, and v is just x squared over 2. So when I start writing this out, I'm going to rewrite this as 1 over y again, dy equals u times v, so it becomes x squared over 2 natural log of x minus the antiderivative of v du, and I can factor out that 1/2 here. And that just becomes 1/2 x dx. And let's see here, this I can now integrate, yay, so we're going to get the natural log of the absolute value of y equals x squared over 2 natural log of x minus 1/4 x squared plus c1. That is a pretty nasty antiderivative. All right, now we're going to solve for y. So this is where we want to be really careful. Right now, you probably actually have 3 points on this question. 1 point for splitting it, 1 point for your antiderivative, and then 1 point for your constant of integration. So you probably got like at least 2, maybe 3 points right here. Exponentiate, e. Now when I e it, this is going to give us the absolute value of y equals e to the x squared over 2 natural log of x minus 1/4 x squared times e to the c1. Remember, this is just this little rule right here from Algebra 1 that if I have a to the m plus n, that's just a to the m times a to the n. I didn't make 3 terms because I kind of want to keep all of these together. It makes it a little bit easier for us. And then we're going to say that famous phrase, let e to the c1 equal c2, and we would get the absolute value of y equals c2 e to the x squared over 2. Whoops, holy cow, what happened there? Don't know. Let's see here. There we go. I think that fixed it. X squared over 2 natural log of x minus 1/4 x squared. Alright, there we go. Alright, now we're going to solve for c2. So we would get y equals, you can say plus or minus c2, but it gets absorbed. So I can just leave this as c2 e to the x squared over 2. What's that becomes? Natural log of x minus 1/4 x squared. And now we're going to find c2 using the condition 1/4. And so if we do that, we would get 4 equals c2 e. This just becomes 0 because natural log of 1 is just 0 minus 1/4. So c2 equals 4 over e to the negative 1/4, or 4e to the 1/4. So my equation there, y equals 4e to the 1/4 times e to the x squared over 2 natural log of x minus 1/4 x squared. It looks nasty, but it's not so bad. I hope you enjoy this. I'll see you all later. And the last one, number 6. Yay, yes.